Hello everyone, my name is Juan Gargiulo. I'm the Development Officer Dairy within New South Wales DPI, and I'm gonna give you a tour on how to use the AMS Integrated Management Model. The IMM provides farmers and advisors a tool for exploring the physical and economic impact of different strategies on AMS. The tool helps to assess and plan the potential investment better and make more informed decisions. Finally, it helps to identify areas of underperformance and propose alternative pathways to optimize the whole system. This tool uses annual economic data from 18 Australian AMS farms and physical monthly data from 28 AMS from Australia and overseas. That data was then used to develop a series of equations and models that sit behind the tool. The app contains a sidebar with different tabs to access to specific content. Most of the content is interactive, with additional information popping up on the screen as the user hovers the mouse on tables, graphs, numeric inputs, and sliders. There are 4 main numeric inputs that you need to enter for the simulations. These are the number of robots, the number of cows in milk, the daily milk yield, and the total labor on farm. Most of the indicators in the tool are presented as interactive gauges. These gauges show the current simulated value and the maximum and minimum observed on commercial farms. The gauges also display a green color if the value is within the top 25% of the farms, yellow if it is within the middle 50%, or red if it is within the bottom 25%. Here you can see how changing the number of cows in milk impacts other variables such as the milk harvested or the cows per robot. In the System Performance tab, you can find more detailed indicators related to the physical performance of the robotic system. There is also a slider input where you can define a milking frequency range. For example, you can limit milking frequency up to 2.5 milkings per cow per day and see the impact on the other variables. In the Economic Performance tab, you will find whole system physical and economic indicators. For example, you will see the predicted operating profit margin and the return on total assets, which are based on the figures you entered before. It is important to mention that in our research we found that economic performance is mainly associated with milk harvested per robot and with other factors such as the total labor on farm. The System Optimization tab shows the current scenario, which is based on the inputs you previously entered, but also you can run an optimization simulation to, for example, find more efficient or better system configurations. The table with the current scenario shows also the probability of achieving a specific performance level, which is equivalent to the colors shown in the gauges. For example, if the probability is 30, that means that only 30% of the farms are achieving that level of performance or greater. If you want to optimize your farm, you can set a milk harvested target, which is first adjusted by default on a 20% over the current scenario. However, you can change it either selecting a range or a single value. In this example, we set 1600 kilos of milk harvested per robot and then run the simulation. Now we have our optimized scenario. This indicates what is the most likely configuration of variables to achieve 1600 kilos of milk harvested. For example, here we should increase the number of cows per robot to 64 and the milk yield to 24.9 kilos. The stars in the ranking also shows the impact that the variable could have on milk harvested per robot. In this example, cows per robot could have the greatest effect. Inputs in the simulation are also set by default based on the current scenario. However, you can change this. For example, we can limit the number of cows or the milk yield if desired. You can also download the tables as a spreadsheet file. Finally, the Benchmarking tab allows the user to quickly compare the actual or expected performance of the AMS to historical data. This section is independent of the rest, and variables are not interconnected or based on a model. The user has to enter the values directly in the tab's body. Default values presented indicate the average of AMS farms participating in this project. Hope you enjoy watching this tutorial, and if you have any questions, please contact us in the address below.